So the first problem is asking how many factors does this number have? All right, I don't know whether I had spoken about this before, but for whatever it's worth, let me just say something about how to count the number of factors of a given number, right? So, so if you take a number like, say, 48, right? If you want to write down the factors, you'll say it's 1 times 48, 2 times 24, 3 times 16. You'll go through all the numbers from 1 to onwards. 4 times 12, and then 5 doesn't go into it, but 6 certainly does. 6 times 8, and that's it. Right? If you go beyond that, you already have 8 here. 7 doesn't go, and 8 is already done. So you have these factors. And how many factors have you got here? The 5 plus 5, which is 10. So 48 has 10 factors. All right. Now, there is an easy way of counting this. If you write 48 as powers of prime numbers, you see, it is 16 times 3, and 16 is 2 to the power of 4 times 3. Right, so if you write it as powers, every number can be written as a product of powers of primes. Right? If you group all the primes together, you get a power of a prime. All right, and the way to count the number of factors is, once you write it as a product of prime numbers, or powers of primes, then the number of factors equals, what you do is, you look at the exponents only. The exponent of 2 is 4, and you increase each exponent by 1. So increase 4 by 1 and multiply it by the same thing for this next prime. So here the exponent is 1, so 1 plus 1. Okay? So you'll see it's going to be 5 times 2. And as we saw, it's 10. See? So there are 10 factors. So you have a very nice way of doing this thing. The reason for this is, if I write down all the factors of 48, and just take the powers of 2 only, you'll have 1, 2, 2 squared, 2 cubed, and 2 to the power of 4. These are the factors of 2 to the power of 4. And this can be matched with 1 times 3, 2 times 3, 2 squared times 3, because you've got a 3 here, and 2 squared, 2 cubed times 3, and 2 to the 4th times 3. So these give you all the factors. If I had 3 squared here, then I'll have to put 1 times 3 squared, 2 times 3 squared, 2 squared times 3 squared, and so on. And there it is, you got your 10 factors. So in other words, you can choose the first factor in 5 ways, you see? 5. That is why you get 4 plus 1. And then for each choice of that, you got 2 ways of choosing the second factor. So that is why the second factor is 1 and 3, 1 and 3, 1 and 3, and so on. So that is why it's 4 plus 1 times 1 plus 1. Okay, so that's the background to this. So if we look at this problem here, the answer is, now these are all prime numbers. So it's 11 to the 1, 13 to the 1. None of them is more than 1. So these are the exponents. So you increase each of the exponents by 1, the first one, and the second one, and the third one, and the fourth one, and multiply them. Right? So it's 2 times 2 times 2 times 2, which is 16. So this number here has 16 factors. So you take each of the exponents and increase it by 1, and then multiply the whole lot. That is a quick way of counting the total number of factors of a given number. Okay. All right, so that now takes me to the next problem. So this collection of problems is dealing with factors of a given number. So here you got find all. Thomas, please don't write on my screen. Find all numbers less than 50 that have exactly 4 factors. Now, how do we solve this problem? So we'll say, suppose the number is n. Let n. Okay, I'm going to write it as a product of prime powers. Okay, we'll make it 2 to the power of a, 3 to the power of b, 5 to the power of c, and so on. So this is, every number can be written as a product of powers of prime numbers. But yeah, a could be 0. Just observe. And then 2 to the a is 1. So the exponents here are integers, which could be 0. So I got dot, 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 dot here, because every number can be written like this. See? Every number can be written like this. Like, for instance, if you take a number like 520, right? When you will see that 8 goes into this. So that's 2 cubed. 3 doesn't go into it. So you can make it 3 to the 0, that's 1. And 5 does go into it, right? 104 times. So it's 5 to the power of 1. And the remaining factor is 13. So when I've done this thing very quickly, but this is the factorization of this. So in fact, we could have written 7 to the 0, 11 to the 0, and 13 to the 1. See, you can write down all the prime numbers, but you can allow zeros. All right. So what does this mean? Now, it means that the number of factors, you see, it tells you that it's got exactly 4 factors. So we've got a formula for the number of factors. The number of factors of n is a plus 1 times, right? Increase the indices, b plus 1 times c plus 1, and so on. Now this product is equal to 4. Okay. All right. So if we ignore the cases where a, b, and c are 0, because then it just gives you 1. 1 is a factor which doesn't tell you too much. The point is you've got a product of a number of numbers which is equal to 4. Then you have to ask yourself, I've got dot, dot, dot here. So now, how can you get 4? Which numbers give you a product of 4? Right? So you can have, we don't want 1 now. You see, if a plus 1 is equal to 1, for instance, then A equals 0. We're not interested in 1 as a 2. The A is 0 means 2 to the 0 is 1. And that gives you, if A plus 1 is 1, it gives you the factor 1, which is really, I mean, we already know that 1 is a factor. So we will assume that all of these are at least 2. So you will have A plus 1 equals 2, and B plus 1 is also equal to 2. So the only way you can get 4 is 2 times 2, right? And then you could have 1 times 4, by the way, right? You could have 1 times 4, but that's it. So, or otherwise, just 4 itself. So we can say, therefore, we have A plus 1 equals 4, or B plus 1 equals 4, or C plus 1 equals 4. One of these is 4 and all the others are 1, so we don't worry about that. Okay, so here you have, in other words, these numbers are all 3. A, B, or C is 3. So you could have n equals 2 cubed, right? So when the powers are all 3, it means that the number is a cube of a prime. So you've got n equals 2 cubed, or it could be 3 cubed. But remember, they are all less than 50. 5 cubed and so on. But 5 cubed is 125. And that's not allowed, because this is greater than 50. So as far as the cubes are concerned, 2 cubed and 3 cubed have got 4 factors. Got exactly 4 factors. And you can see 3 cubed, the factors of 3 cubed are 1, 3, 3 squared, and 3 cubed. It's got 4 factors. So that works, or otherwise, or you'll have A plus 1 equals, let's put it this way, 2 of the exponents are equal to 1. Because now if the exponents are just 1, then you'll have 1 plus 1, which is 2. 2 times 2, you see. So this 4 is equal to 2 times 2. So you're multiplying 2 by itself only twice. So it means that I've increased those exponents by 1. So the original exponents would have been 1. So I'm saying 2 of the exponents are equal to 1. See? All right. So what does that mean? It means that the number is a product of 2 primes. Because if the exponents are equal to 1, so you have 2 times 3, for instance, right? They are, in both cases, you got 2 primes, and the exponent is 1. So 2 times 3 will have 4 factors. But it doesn't really matter which prime bases you've got. So all we can say is that the numbers here are of the form. So for A plus 1 equals B plus 1 equals 2, N is equal to P times Q, where P and Q are prime numbers. Right, I'm just going to discard this 2, 3, 5, and so on. I'm just going to say it's a product of 2 primes where the exponent is 1, right? The only 2 primes in the factors, exponent 1. So it's a product of 2 primes. So you have to look at all the product of 2 primes which are less than 50. So now you're going to have two. It must be distinct primes. You can't have them the same. So you can have 2 times 3, 2 times 5, 2 times 7, and so on. If you make one of the factors 2, but if you want it to be less than 50, you can only go up to 2 times 23, which is 46. And after that, the next prime number up to 23 is 29. 24, 25, 26, 27, 28 are not primes. So 2 times 29, but 2 times 29 exceeds 50. So you only can go up to this. Or you could have 3 times 5 or 3 times 7. And how far can you go up to this? You can go up to 3 times, you can't go to 3 times 17 because that is 51. Right? 3 times 17, so you can only go up to 3 times 13, and so on. If you take 5 now, you can have 5 times 7, but that's it. You can't go to 5 times 11. That doesn't work. So this gives you all the possibilities. So you can count the 2 that we had, and we had these were the only cubes. So those 2, and you count all these, and you'll know the total number of, you can write down all the numbers which are less than 50 that have exactly 4 primes. Okay, so the trick there is that the product of these a plus 1, b plus 1, and so on is 4. And that's very easy to see which 2 numbers or which 3 numbers add up to 4. It's only 2 numbers. You could have 1 times 4, or otherwise just 4 by itself, or you can have 2 times 2, right? But we don't want to put 1 in that, because the 1, if a plus 1 is 1, then a equals 0, and then you have the prime to the power of 0, which doesn't really, we're not counting that. Okay, so that takes care of this next problem. The third problem is so we learned a couple of things here. The most important thing you learned is that you can count the number of factors. If you write the original number as a product of prime numbers, every number can be written as a product of just not prime numbers, but powers of prime numbers. You can't say product of prime numbers, but if you group the same primes together, then you're going to get a power of a prime. Okay, so that takes care of problem number 2. Let's go to now problem number 4. It is problem number 3. How many factors does the number 600 have if 1 and 6 and 100 are included? So you must include 1 as a factor and 600 as a factor. Now this is 600. You can try factorizing this. 8 goes into this, 2 cubed times 75, and 2 cubed. 3 goes into this. This is 3 times 25. So this is the factorization of 600 as a product of prime powers. And the answer is how many factors it's got. We already would have, I'm not going to even write the formula. You increase each of them by 1. Right? The exponents, 3 goes to 4, 1 goes to 2, and 2 goes to 3. And you add this, you multiply that, and you got 24. So this number has got 24 factors. 600 has got lots of factors, 24 factors. You can actually write them down. To write down the factors, normally I'll start with, as I did earlier on, I'll put 1 times 600. And then I'll put 2 times 300, and so on. I keep going down. And the last one you'll come to is 24 times 25. That's also 600. But you can't go any more beyond that, because the next one is 25. 25 goes into this exactly. But then you'll come back to the same thing, 25 times 24, which we've already counted. So you could have listed all the factors like that and counted them, but that would have been very tedious, and we have a nice, lovely formula which gives you the answer without even writing the formula down, which is powerful, without even writing the factors down, at least. So the next problem is number 5. It says your 1287A45B is an 8-digit number. Yeah, you can see it's got 8 digits. So A is a digit and B is a digit. So you got a large number, 12 million something. But 2 of those digits are missing. But it's given that A and B are not 0. So this means that A is equal to 1, 2, 3, or something like that. It's not 0. The same with B. B is 1, 2, or 3. Okay. Now the next one is the number is divisible by 18. So 18 goes exactly into this. Now let me write down 18 as 2 times 9. So 18 is a factor. I think I said that there's a notation for factors to say that 5 is a factor of 15, for example. You use a nice notation like this. You put 5 with a vertical sign, 15. Now that doesn't look too vertical. This means the 5 is a factor of 15. See? Or 1 is a factor of 15. In fact, 1 is a factor of everything, and so on. So if 18 is a factor, the number is divisible. So 18 is a factor of 1, 2, 8, 7, A, 4, 5, B. So it means that 2 is a factor. Which means that B is even. But B can't be 0. Eh? So therefore B is equal to one of these numbers, 2, 4, 6, or 8. So we've zoned down on B. There are only 4 possibilities for B. And the reason for that is 2 is a factor of this number. And when 2 is a factor of any number, it means the last digit, which is B, must be even. And that's what I'm saying here. Now, 9 is also a factor. Now, we know a rule for divisibility by 9. Right? This sign which I'm using here means implies. It's a way of saying that if this is true, then this is true. Right? Instead of separating by commas, you can put the sign here. It's a very useful sign. So if a 9 is a factor of any number, it means that 9 is a factor of the sum of the digits. So you got 1, 2, 8, 7. You add up all these things, 18, so it's 27 plus A plus B. When you add up all those digits that we can see, right, the 9 is a factor of 27 plus A plus B, but 27 is already a multiple of 9, so you can say 9 is a factor of A plus B. Right, so 9 is a factor of A. Okay, so what does this mean? A and B are digits, right? A and B are digits, so they're 1-digit numbers. So for 9 to be a factor of a plus b, you can only have a plus b equal to 9. Well, 0 or 9 or 18. 9 is a factor of 0, by the way. 9 times 0 is 0. Now, this is not possible because if two integers add up to 0, then both of them are 0. And we are told that it's not 0. Now, for this case here, a plus b equals 18. The only way you can get two digits adding to 18 is if both of them are 9. A equals b equals 18. Right. I'm sorry, a equals 9. If it's 18, so if this is 18, there's only one way of working that out. But in this case, the difference is, see, the question is, what is the maximum possible difference between A and B? And in this case here, the difference is 0. The A and B are 0. Okay. Now, the other case is if A plus B equals 9. That's a possibility. So in that case, A, B, two numbers, digits adding to 9, you can have 0 plus 9, but you're not allowed to put 0. So you can have 1 plus 8. AB is 1, 8, they add up to 9, or 2, 7, or 3, 6, sorry, 3, 6, or 4, 5. These are the possibilities for A and B, because they add up to 9. Right. The maximum, and the differences are, you can work out the maximum difference. You can write it down straight away. Max diff. Sorry, I'm squeezing this in. The difference between A and B is 7 here. Here it's 5. Here it's 3. Here it's 1. So the largest difference is 7. Maximum difference is 7. That's 8 minus 1. And so the differences can be 0 or 5 or 3 or 1 or 7. And you want to know what is the maximum possible difference. Of those numbers, 7 is the largest. So the answer to this problem here is 7. Okay, so that now takes me to the next problem. If there's any question that you need to ask or any comment you want to make, you're free to make that comment in the chat column. Like yesterday, I was giving a class and somebody made an interesting comment in the chat column, corrected an error of mine, which is very nice, because then I didn't have to regret that I gave the students the wrong answer. Now, let's get to the next problem. The next problem says, oh, this week's assignment. So you got 2 problems this week. I know that some of you are writing exams. Hopefully your instructor will give you more time. I think they are doing that. So you have to think about these problems here. I haven't done any of any types of like this, but as I said, you have to think it out yourself. So I think you got sufficient information to work out the first one. And the second one is a logical problem. There are two problems. The second one is a logical problem. Now, let me just make a comment here. When 2024 is divided by n, a remainder of 15 is left. Now, just be careful there. If the remainder is 15, then your divisor will have to be more than 15, right? The remainder is always less than whatever you're dividing by. When you work out, when you're dividing by 8, your remainder will be less than 8, right? So that information tells you that n has to be, right, I'm not going to tell you anything more than that. But for the remainder of 15, your divisor must be larger than 15. Okay, so, and the next one is a logical problem. You can try this thing out. And I'll just give you a clue here. Session 11, number 6. Give you a clue. See, there are several possibilities in this. These two guys are either speaking the truth always or they're speaking lies always. So you can have quite a few possibilities. But the clue I'm going to give you is that you prove by contradiction. In other words, you assume that one of them is a liar, for example, and then prove that it's impossible. Right? And then you'll say, well, if that is impossible, it means that the guy speaks the truth. See? So you make an assumption, like, suppose this guy is a liar. Then you look at the statements he is making, and you will say, no, these are all lies. Right? So then you can decide what the true statements are. And then once you do that, then you can go towards the answer. But if you lead up to a contradiction, then it means that your assumption that he's a liar is false. Then you'll say, this guy is actually a truth teller. Yeah? And that pushes you into a closer towards a solution. Well, I don't know. I hope you understood that. But this is a proof by contradiction. In other words, you assume something and prove that it's not true. Okay, number 7, the decimal form of, actually, is something I'm missing here. It's actually 3/7. So the decimal, if you take 3/7 and if you work it out as a decimal, you will see that you will get this number that we are getting. Now I do it like this: 3,00000. 3 goes into, so this goes 0 here, and 7 goes into 34 times. Remainder 2, 7 going to 22 times. Right? That's 14, remainder 6, and so on. You can see what's coming out. So you'll have 42871, but this thing just keeps repeating like that. So this is what you call a recurring decimal. The numbers recur. It keeps, there's a certain string which keeps recurring. Like for instance, in 1/3, you'll have 0.33333. So 3 is a recurring decimal. Yeah. Or you could have 1/5 is 0,2, but then you could have put zeros right throughout. So these are recurring decimals. In fact, whenever you have a fraction and you write it as decimal, you'll always have a recurring decimal. That's a useful fact, right? Every fraction written as a decimal, in decimal form, is a recurring decimal. Okay, that's a useful fact to know. Now, that's got nothing to do with this problem, though. This problem says you got this thing that is repeating like this all the time. What is the digit in the 2024th place? Okay, so you can say the following. 4 is in place, well, the first place is 1. The second place is the 7th one. And you can go on, 13th one, 19th one, and so on. Those are the places where 4 goes. And there's nothing interesting about this sequence here. But you can try, even 2 now goes into the 2nd, and the 8th, and the 14th, and so on. But the interesting one is 1 is in the 6th place, and the 12th place, the 18th place, and so on. Right. Now, these are all multiples of 6. So whenever you're looking at a number in this decimal expansion whose position is a multiple of 6, then the number at that position is 1. That's very useful. So when you go 2024, right, and you want to see which is the closest multiple of 6, which is this. See, you got this, and the 2024th position. This is what we don't know what this is. But we know this is the 2024th. The one before that is 2023rd, 2022nd, and so on. But we know that a multiple of 6 will have a 1 in it. So we look for how many 6s are there in 2024. So when you divide this by 6, you get 3, I think 337. Remainder 2. Remainder 2. So in other words, 2000, this is 2024 is 2022 plus 2. The remainder is 2. So if you take away 2 from that, you come to this. Now this is a multiple of 6. You can see it clearly. It's an even number. And when you add the digits up, you get a multiple of 3. So this is a multiple of 3, and it's also even, so it's a multiple of 6. Okay. So why am I doing all that? It means that this number here, the 2022nd number, that's a multiple of 6. Right? Is 1. Because all the positions at the multiples of 6 are 1. All right, so now, then the next one will be, if you look at the sequence, the next one is 4, 2023rd is 4. And the question is, what is in the 2024th place? Right, so you got 1, 4, has to be 2. Right. This is 2022, 2023, 2024. Okay, So the answer is 2. The reason is the 2020 second one is a 1. The next one will be a 4, and the next one will be a 2. Okay, so that's how you work that problem out. So that problem really involves division by 6. Find the quotient and find the remainder. And then we want to know how many 6s there are in 2024. That was essentially the question that we needed to do. And not really. The question was not that, but it implies that you have to see how many 6s there are in 2022, right? And you need a remainder which is less than 6. So you divide 2024 by 6 and see what the remainder is. All right, so that takes care of this one. I'm actually very tired. I drove 337 kilometers today. Well, I didn't drive, but I had to go to a place which was 168 kilometers away. I came back straight and sat here. So my eyes are drooping. So if I go off to sleep while I'm talking, you have to forgive me. Okay, here you've got a 24-digit integer. Oh, there's millions of ones. Okay, it's got 24 digits. Is divided by 1111. A long time ago, I did this problem with a group of teachers, and they couldn't, for the life of me, solve it. They couldn't understand how you can do this without a calculator. But it's very easy. I I normally put down, I divide like this. Unless it's long division, then I'll put this thing at the top. But I can actually divide this thing without long division. I got 111. I got 24 ones here. What I'm going to do is divide this into groups of 4. So there are 6 groups of 4. 1, 2, 3, 4, 5, 6. Right. And I've separated them because now I can say this goes into this one time, right? And the remainder is 0. So you'll have 0, 1, and here you have 11, here you have 111, and 1111 goes into this one time. Right. So it stops there. The same way you have, it's like this. You see, when you're dividing by 111, there are lots of zeros, but there will be a 1 at the end, right? Because 1011 is 1011 times 1. Okay, if you don't understand that, you can try something else. Like you could have tried just this. Suppose you got only 2 of them. So this goes into this one time. The remainder is 0, right? So you got 0, 1 here. 1011 goes into the 0 times. The remainder is 1. And 1011 going into 11 0 times. And then you put 11 here. And 1011 goes into 111 again 0 times. But the last one is 1. That is how we get this thing here. Question is, how many zeros are there in the quotient? This is a quotient. You can count the number of zeros. 1, 2, 3, 4, 5. So each group has got 3 zeros in it, and there are 5 groups, so the answer is 15. Okay, so that takes care of that problem. Okay, the next problem. Is that one. P and Q are natural numbers. And when P is divided by 2Q, the remainder is 10. What is the remainder when P is divided by Q? I'm not sure whether I've done this problem. It seems to me that I've done it a couple of times in the last 2 weeks, but I've got all different classes. So P and Q are natural numbers. When P is divided by 2Q, the remainder is 10. What is the remainder when P is divided by Q? So if the remainder is 10, it actually means that when you're dividing by 2Q, so there's 2Q, and you're dividing P by 2Q, you get some answer here, but the remainder is 10. Which means actually that 2Q, this divisor, to get a remainder of 10, 10 must be smaller than 2Q. Right? You got to, when you are dividing by something, the remainder must be smaller than whatever you're dividing by. Right? And that means that 5 is smaller than Q, cancel the 2's, and you say that Q is greater than 5. Okay. Okay, that's just an observation. Now, so when P is divided by Q, you can say P over 2Q. You can make it into a fraction like this. Right? The remainder is 10. So in other words, you got a whole number. So you got something and you got a mixed fraction. You'll have a mixed fraction, and the remainder will go on the top of that. See? Like if you're dividing 8 by 15, then 15 is 1. 8 goes into this one time. The remainder is 7, and you put 7 over 8. Now this is what you have done in primary school. But just bear in mind that you're dividing this by 8, and the remainder goes to the top. Okay? So what we've got here is the remainder is B. You got something, like that. This is the remainder here, right? And this is 2q. Because when you're dividing p by 2q, then you'll have something and this over 2q. So you got something, this is 2q. So it looks as if the 2q, and now you want to know what is the remainder when p is divided by q? Right? Let's try some numbers. I think some piece of information is missing here. Um, let's look at some numbers where the remainder is 10. I'm going to try some numbers here. Okay. I'm going to construct some situations where you got something divided by an even number. So suppose I'm dividing by, say, 22, and the remainder is 10. So you're going to get a multiple of 22 plus 10. So you got like that, right? So you've got, if you look at this, if this is P and Q is 11 now, so this becomes 2Q. And this is a situation where when P is divided by 2Q, the remainder is 10. 44 plus 10, right? Now Q is 11. So when 54 is divided by 11, what is the remainder? Now you'll see the remainder is still 10. 11 goes into 54 4 times, and then you get 10 over 11. So the remainder is still 10. So there's something missing in this thing here. I think I changed the question a little bit, and it becomes meaningless. The actual, if I remember correctly, you get 7,25 or something like that. Just 29 over 4. Huh? So they say that this thing is divided by 2q, the remainder is 10. So at the moment now, the remainder is 1. But then when you multiply this by 2, this is the same as that. Now the remainder is 2, you see. So you have to multiply this by 10. The same fraction can be written in so many different ways. So if you multiply this thing by 10, then you got 280 or 40. 40 goes into this 7 times, and the remainder is 10. Okay. So this is what P is, and Q would have been 20. Because P is divided by 2Q. All right. So this is Q is 20. And now, if you see what is the remainder when P is divided by 20, the remainder is still 10. Right? Okay. I'm sorry, that question was badly phrased. There's something missing in that question. Uh, let me just look at, I think I've got the answer here somewhere. Let me just come out of this and see what I did. Just one moment, please. Hmm. Okay, I won't waste your time. I can't seem to uh, operate this thing nicely. Okay, let's just go to the last question. So I'm going to share the screen. Which one am I going to share? I think it's the same one. Okay, this is the last question we're going to do for today. And this, I think there was something wrong in the last question. I'm not sure exactly what's going on there. Children at a school fun day had to guess the number of marbles. This is a very nice question, right? Uh, Children at a school fun day had to guess the number of marbles in a jar. All right. So prizes were awarded on how close the guesses were. Okay, that's understandable. The first prize went to Emily, who guessed 125 marbles. So Emily guessed. Emily said the 125 marbles, and she came first. The second prize went to Cassandra, who guessed 140. Let's call her Cass. So she said 140. She was second. And the third went to Sigrid, guessed 142. Oh, the fourth prize went to Rena, and she guessed 121. Okay. So how many marbles were in the jar? All right. So we have to see now. The second prize went to Cassandra. So Emily was closer to the answer than Cassandra. Okay. So it means that the number of marbles in the jar would have been, now if you write down all the numbers, 125, 126, and so on, all the way up to 140, whatever the number is, number of marbles in the jar, she was closer than that. Okay. So it means the halfway down here, you get 126, 130, 131, and so on. If you take the average of these two, you get 132 and a half, right? So, so the number is actually equal to one of these numbers, 125. She might have guessed the exact amount, 126, 127, or 132, right? Now, and now the distance between her answer and this will be less than or equal to 7. Now, and in all the other ones, the 133, 134 up to 140, right? You will see those numbers are greater or equal to this. Yeah. So she came second. So her choice was 140. Okay. So she is further away from the actual answer than Cassandra. So the number is one of these, because you notice that 140, the distance from 140 to every one of these is more than 8. Closest number is 8. Right? So Emily's answer is 125, so she came first. So the number is one of these. Now, as far as Sigrid and Rina is concerned, third is Sigrid. So she was closer to the answer than Rina. Now, if you look at these, if you add these two up, you get 263. I want to see what the halfway number is. So you have 131 and a half. Okay, so let's look at the correct answer is here, 121, 122. But she's third, you see. So she's even further away from the answer. So 142 is third. So 142 is closer to the answer than 121. Okay, so the answer would be uh, 131. Let's look at this. 132, 133, going all the way up to 142, right? And she is closer to the answer than Sigrid or Rina, who cost 121. So the answer, if this was the answer, then 10 and 11. So this is closer. So this can't be the answer. So this one here is a possibility, because 132 is 10 away from 130. 142 is 10 away from 132, and 121 is 11 away from this answer. So therefore, she is better than that. So 132 is a possibility, and it is here. So that's the answer, 132. Okay. There is a nice logical way of doing this thing, but I can't remember exactly what it is. But this is by trial and error. You can see the answer has to be 132, because then 132 is only 7 away from there, but it's 8 away from 140. So 7 and 8, that's first and second. And in the other case, it's 11 and 10. So that's why they come third and fourth. Okay, so the answer there is 132. All right. So the argument is that whatever the answer is, you have to see which number is closer, and it will have to be in a certain set. So in the first place, it's going to be a number up to, it's going to be there, and in the second place, it's going to be there, because 142 is closer. So the only number which is in both of these is 132. So you can see that Yeah, that's the way to do it. So Emily said its her answer was 125. So she is in that set, and Cassandra will be in the other set. So yeah. Okay. So thanks very much for that. This is, I'm sorry, I'm a little bit all muzzy today because after that long drive, I just came straight into this class, and normally I would have gone to sleep and rested. Thank you very much. Right? And I wish you the best for Saturday, which is 2 days away. Whichever team you are, we hope that your team wins. Or even if it doesn't win, there are something like between 40 and 50 teams that take part. So if if your team is in the top 10, be happy that you have done very well. All right, and I do hope that you benefited in some way from this class. Thank you for attending, and I'm going to close the class now. So we actually closed a little bit earlier, although I started late. We didn't have too many problems to study today. Okay, I don't know whether I missed out any problems, but let me see. There's nobody in the chat column. So there were not many